Okay, back to this again. And now we're going to put all that newfound knowledge to good use. Right now, all the agents are dropping straight down when they're triggered, and I want to apply some force right at the position where they get hit. The first step to do this is to get the actual hit position, and then see what agent transform is closest to that position. And I'm back here in this attribute valve here. If you remember, it was looping through the different bullets, and then it was raycasting backwards to see if it hit the agent, and if it did, it set hit to 1. But we will need some more things now. The first thing we need to save out is the position where the agent gets hit, and we can get that from the intersect node here. The second thing we need is the direction of the bullet, so we can apply the force to the agent in the same direction. And for this, we can get the shot deer we use for the intersect ray direction and inverse that. I could do what I did with this two-way switch, and do that 2 more times, but I'm actually going to use an if block now instead. So an if block works like this. The condition is true, it's going to do whatever is going on in here. A very easy concept. Let's see if it's hit. This compare here is a test to see if the agents get hit or not. If the agent is hit, I want to save out the position. So in the first port here, and I also want to have the shot there. Let's do that in here, and then I'm going to drop down to bind exports. First I'm going to do a hit position. I'm going to call it hit pos in there, and I'm going to copy this guy, and I'm going to use this for the hit direction. Hit there. Right. I got an error here, but I just middle clicked the node to make it go away. Another way to get rid of these false errors when they are more persistent is to do a Control X and then just do a Control Z. But anyway, now this should be working, so let's go out and do a spreadsheet. Oh, like this. And let's see if they get hit. You can see that guy get hit. And by the way, here's also the reason why I kept this as it was, because I want this hit value to just be one of the frame where he gets hits, and then I want it to be zeroed out, so it does that. But when I do it this method, you can see that he just sets the values, and then it's going to be these values until another value is set. Yeah, you can see that they stay the same. Okay, we have the hit position, and now it's time to get the position of all the limbs for each agent. And this one, I just want to run it on points where the hit is 1, so only on the frame when the hit value is 1. So I'm going to do at hit equals to 1. I'm going to run this over points. So like so, and I'm going to call this check rig. Let's go in here, and as you remember, we need to get the transform from the agents. So let's drop down an agent transforms. And I connect this in here, and this to the prim number. So, and I also want this space to be world, and then I need to loop through this, because now this is just brought into an array. So let's do a for each here, so we can go through the array, and then connect this into this, so like so. And now for every iteration, is this element out will be the matrix for that transformation. As you also remember, this didn't take in the scale and the position and orientation of the agent, so we need to multiply that in to get it to work. So let's drop down a prim intrinsic and connect that in here, and here prim number, and here I'm gonna write pack full transform, and this also needs to be a matrix 4, and I'm gonna drop down and multiply like so, and then I want to extract the position from this, so I'm going to drop down extract, like so, and let us just see so this works. So I'm going to drop down an add, or an add point rather, and I'm going to connect that into here, and let's see. Actually, it doesn't work. So, it doesn't work because no one is hit on this frame. So let's go to see someone is getting hit. There, that guy gets hit. And then you can see all the points are in the right places. So let's delete that guy. Cool. So now we have this. So what we need to do now is we need to take in the hit position. So I'm going to do a bind, and then I'm going to do hit pos, and I'm going to use a vector. And I want to check the distance for these guys. So cool. Now we have a distance. And what we're going to do is we're going to loop through, and we want the one that has the shortest distance to the hit position. So let's do that. So let's first drop down a constant here, and I'm gonna plug that into this here, because this is the value I'm gonna compare to, because it's gonna iterate over and over again, and then this will always have what currently is the shortest distance. If we compare these two guys, so if this new distance is less than the old distance, then we want to save it. This is not enough though, because on the first iteration before any distance has been saved, the old distance will be 0, and there will obviously never be a shorter distance than 0. So let's drop down an OR. Either this is true or this other thing is true. What we're going to do there, we're going to check if this is 0, that means that this is the first iteration, and then we also want to save this value. Cool. We can do this two ways, but I'm going to use the if block for this. So let's do the if block. I'm going to connect this in here, and I'm going to take this value, I'm going to plug that in here, because what this means is if this is false, the value will go unchanged through the if block, but if it's true, whatever happens in the if block will come out. So if it's true, then I want to have the actual distance, like so, and then I'll connect that at the end of the for each block, because as you remember, this will make the for each remember the value in the next iteration. So now we have a working loop. The other thing we want to have is that we want to take the current index here. If we know the position in the array, we know what limb we're going to use. So let's take and just plug that into the second one there, and then I'm going to drop down a bind export, and it's going to be an integer, and I'm going to call this rig ID. This rig ID will now store the array position of the transform that is closest to the hit position. Cool, we're almost there. So now we just need to apply some force to this. But let's do that in the next lesson.